All right. But let's talk about an equation of a plane. Now, if we think about making a plane, 2 points determine a line, but do you know how many points determine a plane? Because if we just have 2 points, I mean, we could make that be this plane, but we could also do a plane like that, couldn't we? Or a plane like that. So 2 points don't determine a plane, because there's lots of planes that would intersect 2 points. You need 3 points. You need 3 points to determine, infinitely many planes through 2 points. You need 3 points to determine a plane. You need 3 points. There's one way to do it. Or, how else could we do it? Well, we could also do it with 2 lines. 2 lines determine a plane. So if you've got a line here, then you've also got a line. Gets a little tougher to draw in on 2-dimensional plane. But let's say we've got another line that comes through like this. Okay. So you got a line here and then a line kind of like that. Well, that also determines your plane for you here. Because for those two to lie in the plane here, I mean, your plane has to go through has to contain those 2 lines. I'll say it right here in a second. But that also determines your plane. So if you got a line, I guess I can try to. So you got a line here, and then you got a line kind of intersecting here. That you got a plane. Okay. Or your line's here and your line's here. Well, there's your plane. Okay. So that tells you how to tilt. So if you move one of the lines, then that changes your plane. Okay. So you need 2 lines. All right. Well, here's the other thing, and this is where we'll get our equation of a plane from. If you've got a point then in space, and we want to talk about a certain plane, whatever wherever it is, however it's tilted. Another way you can do it is you can get a point out of that plane. So this is our plane surface. You can get a point out of that plane, and then you can do a perpendicular vector to that plane. Because if you know something that's perpendicular, there's no way around it. You got the point and you got the perpendicular. That plane, because if you shift that plane at all, that shifts the perpendicular. And so that's the way. So you got a point and this perpendicular vector to that plane. And so we've got this vector that's perpendicular to it. That vector is going to be called the normal vector. think we mentioned back in Calc 1, talk about the normal line to a curve. This is the normal vector to a plane. And it's going to be designated for obvious reasons with an n. N is going to be this normal vector. Now, the thing about n is it's perpendicular to the plane, which means it's perpendicular to any line that I draw in that plane, or any other vector or line that I draw in that plane. It's going to be perpendicular to that one, it's perpendicular to that one. If you got another vector or line in that plane, it's perpendicular to that. Okay. All right. Now some other notation here. N they're going to represent with the ABC, because that's just going to be the given information. Well, one way we're going to do it is with that given information. Okay. Now, our original point, also x0, y0, z0, just like we started with on the equations of lines just a second ago. All right, now we can pick any other point out in this plane, and so for just convenience here, let's say I pick out this this point somewhere in that plane, call it x, y, z. I could do the same thing here, call that x, y, z, or any other point in that, and do this very same thing with. What I'm going to do then is make that vector from x0, y0, z0 to this x, y, z, and we're going to call that, I believe they call that r. Yeah. Okay. Now what do we know about a vector? So this vector, and how are these vectors related? I've got it right there. It's perpendicular, orthogonal. And what do we know about orthogonal vectors? Dot product is 0. So n dotted with r must be equal to 0, because they're orthogonal, perpendicular. Well, what that does is we've got n is this ABC. Now I haven't written it, but the way I've generated r, how could I get the vector components of r? Subtract. Okay. So I subtract. And so I dot that, so x minus x 0, y minus y 0, z minus z 0. So if I dot that with the ABC, what does that make? So it'd be a times x minus x 0 plus b times y minus y 0 plus c times z minus z 0. Okay. All right. So yeah, this is, so we think about what we're given here. We're given the normal vector. We'll be given that, or be able to find that normal vector. And then we're given this point, this x0, y0, z0. And so what this does is this sets up a nice little equation for a plane. Because, you know, again, a plane just made up of infinitely many points. But this defines the relationship amongst the x, y, and z points all in that plane. Because this is a number, this is a number, this is a number, this is a... So it gives us a way to find all the points in that plane. Mm-hmm. That's right. So this right here is equation of a plane through the point x0, y0, z0, and perpendicular to this normal vector ABC. Or another way to say it, with normal vector ABC. They'll just word it different ways, but another way you could phrase it. Okay? All right, so let's try a couple of problems here on this. Do what? Yeah. 2 lines. We could use 2 lines, and don't know if we'll do that today, but yeah, we'd have to do. Well, I mean, you'll use this, but you have to use, depending on the information given, you have to use different things. So let's just do one. I guess the easy one. Okay. All right. So find the plane with through. Just to see what it looks like. 1, 2, 5, and that is perpendicular to the vector -2, 0, 4. So the equation is a times x minus x0, b plus b times y minus y0 plus c times z minus z0 equals 0. And so this is the easy one because we're given every piece of information we need. What is the 1, 2, 5? That's our x0, y0, z0. And then the -2, 0, 4 is the ABC because that's the way it's set up. Okay. All right, so it'd be -2 times x minus 1 plus 0 times y minus 2, which really doesn't matter because that's 0. And then c is 4 times z minus 5. Of course, that one would shrink down since that's 0, but you can do different things. Yeah, -2x plus 2, of course that's 0. 4z minus 20 equals 0. I'm not sure exactly how the book, I don't know if they usually leave it this way, but you can get, what does that make it? -2x plus 4z minus 18 equals 0, or -2x plus 4z is 9. I'm sorry, 18. And if we divide by 2, you get, standard form, point form, I guess. Yeah, so there's this form. I guess you could almost, with that form, you get this form. So, not sure. I guess we could look, depending on which book or which website you're on. But anyway, all those would be determining a plane that is described there. All right. Let's do one more here. Okay. So let's say we want find the equation of the plane. through 210, negative 305, and 142. So we said we also had 3 points. That determines the plane. But the thing is, the way we describe this equation, you need a point, but you also need the normal vector, the vector perpendicular to that plane. So how are we going to do this? Well, let's first of all get 2 vectors, because what do we know about in our past, a couple of days ago probably, that we can generate that's perpendicular to something. Didn't we talk about, if we had 2 vectors, we do the cross product, and that's perpendicular to both vectors. And so that's what we're going to do here. We're going to get these 3 points, and we're going to get 2 vectors out of those 3 points, and then do the cross product, because we know that's a vector perpendicular to something. Doesn't matter. We can choose whatever we want to, but what we can do here is, let's say this is P, Q, R. This is the way I will designate it. Let's choose one of them to be our initial point. Let's choose P for make it easy here to remember. So let's kind of let this be our point that we're going to focus on. And so the 2 vectors we'd want then, let's get the PQ vector, and then let's get the PR vector. Right? Because that'll kind of set up our plane, wouldn't it? Because if we do, here's P, Q's over here, so we go there, and then we go here for the R, wherever it is. And so that kind of gives us our the way this is set up. Or one way we could do it. We could do the same thing for the Q or the R, because anyway, all right. Well, the PQ vector, same drill. How do we get the PQ vector out of this? You subtract them. So we got negative 3 minus 2, 0 minus 1, 5 minus 0. So it's negative 5, negative 1, and 5. Then the PR, subtract those. 1 minus 2 be negative 1. Let's write it down. 1 minus 2, 4 minus 1, and 2 minus 0. So that's negative 1, 3, and 2. So that gives us 2 vectors that we can work with here. All right. So to get the normal vector, then we do our cross product. The cross product, the resulting vector there is perpendicular to these 2 vectors, which in turn is perpendicular to the plane, which means it's the normal vector. And so we do the cross product. So negative 5, negative 1, 5. Cross that with negative 1, 3, 2. Remember how we do that? It's a little more complicated. If we set up kind of a determinant here, this cross product, call this the I, J, K across here, then you just put your negative 1, negative 5, negative 1, and 5, negative 1, 3, 2, and then do your cross product thing. You take the I times the determinant here, So that'd be negative 1 times 2 would be negative 2 minus 5 times 3, 15. Then we subtract the j, and it's the 2 by 2 determinant here. So it'd be negative 5 times 2 would be negative 10. 5 times negative 1 is negative 5. And then the k, eliminate that and just do the determinant of these two. So that would be negative 15 plus 1. Sorry, minus 1. Did I do that right? So we've got, however you want to write it, negative 17i plus 15j minus 16k. Does that sound right? I've got something else on my paper, so let me check it. All right. So I is negative 2 minus 15. I don't know. Oh, which one on my paper? The first two, I've got something different. I think that's right, isn't it? I could have written my problem down differently. Looks like the same. Oh, well, okay. I think it's right, though. Okay? Maybe my paper's wrong. Okay. All right. So, anyway, that's a cross product. So this one, this is our normal vector then. The vector that's perpendicular to this plane. So how do we get the equation then of our, so yeah, that's our normal vector, which is ABC. Or AI, in this case we've got AI, BJ, and CK. All right, so the equation of the plane then, well, we better go with this one since this is the one, yeah. This is our x0 since that was the one chosen to do these vectors with as the initial point. So this is our x0, y0, z0 point right there. So it's a times x minus x0 plus b y minus y0 plus c minus z0 equals 0. And so we've got it all, don't we? It's negative 17 times x minus 2. Positive 15, y minus 1. And then minus 16 for c. C minus 0, just z. So depending on how they want that formatted, but that would be the equation of this plane.